Hello friends, in this video we are going to see whether Python programs are compiled or interpreted. Basically Python programs are hybrid. That means they are compiled as well as interpreted. So now we are going to see how the Python programs are hybrid and how the execution of Python programs is different when compared to other languages like C and Java. And also we are going to see what is a .pyc file and what is the use of it. Before going to the demo, let us understand the basic execution of different programs like C, Java and Python. When we write any program, that program which consists of different instructions, and these instructions need to be executed by CPU. CPU can understand the instruction only in the format of zeros and ones. So we need to provide the input to the CPU as machine code. That means the code consists of only zeros and ones so that the CPU can understand and execute it. One thing we need to understand here is that we have different types of CPUs with different vendors like Intel, AMD and so on. So the execution of instructions will be different to each of the CPUs. So for the same program, the machine code which will be given as input to the CPU will be different when compared to other CPU. So when we write programs in high level languages like C, C++, Java and Python, the CPU cannot directly understand the source code. So we need to convert the source code to a binary format so that the CPU can understand and executes it. In case of C and C++, the compiler will convert the entire source code to a binary format so that the CPU can understand and executes it. So here the machine code is platform dependent. That means the compiler which produces the output in one machine may not be executed by another CPU in another machine, because the CPU in another machine may not understand the binary code which is produced by compiler in the first machine. If we want to execute the source code in different machines, so we need to recompile in every other machine. Nowadays this problem can be solved by using cross compilers which can compile the code to different targets. That means in one machine we can run the compilation to a different target. That means we can produce a code which can be executed by the CPU in other machine. But as in principle, these C and C++ binary codes are not portable. That means they are platform dependent. In case of Java source code, the compiler compiles the source code and it produces a bytecode. So this bytecode is intermediary. That means it is not directly a machine code. So we have another part called JVM, which is an interpreter which takes the bytecode as input and it produces the output as machine code, which can be understandable by the CPU. So here we are using the combination of the compiler as well as the interpreter. Here the interpreter is JVM. Here the bytecode produced by compiler in one machine can be executed by JVM in the same machine or the JVM in other machine. That means the bytecode produced here is platform independent. It can be executed in any machine which has JVM. Here the bytecode is portable. So here the execution is like we provide the source code to compiler, it produces bytecode and this bytecode will be given to JVM. So JVM interprets each of the instructions in the bytecode and it converts corresponding code to machine code, and CPU will execute the instruction which is in the binary format and produces output. So the difference here when compared to C is it has both compiler as well as interpreter and it produces the bytecode which is portable and platform independent. When we come to Python, it is almost similar to Java. That means it has compiler as well as interpreter. Here the interpreter is Python virtual machine. That means when we provide source code to compiler, compiler compiles the source code and it produces the bytecode. The bytecode will be given to PVM or Python virtual machine, which is an interpreter. It takes the instruction one by one from the bytecode and it converts corresponding code to machine code, and CPU will execute the machine code and provides the output. Here the compiler will produce the bytecode in terms of .pyc files. So these .pyc files can be portable to other machines where the Python interpreter can convert that bytecode to machine code. So then what is the difference between Java execution and Python execution? In Java we have separate compiler and interpreter. That means we compile the code separately and we execute the bytecode separately. But in Python, the compilation as well as execution happens simultaneously. We do both compilation as well as execution at a time when we execute Python programs. So if required, we can take the bytecode which is produced by the compiler and we can port that bytecode to other machine so that there we can directly execute the compiled code instead of recompiling the code while execution of Python programs. Now let us see in the demo how this Python compilation and execution happens. Let us start the demo with C programs. So here I have written a small hello.c program. This is a very small program which prints hello world when we execute it. So before execution, we need to compile the code. Here we are compiling the code in Ubuntu operating system. Let's do that. For compilation, I'm using GCC. So we need to provide the input hello.c here. So the output of the compilation, I'm giving the name as hello bin. Now the compilation is fine. So this hello bin is the compiled code, which is a machine code. So let us try to execute this hello bin. Here we can see it is printing hello world. That means the code is executed successfully. Now let us copy this hello bin to a different operating system like Windows. So there, if we run this program, it should not run successfully because this compilation output or binary is generated for the CPU in this machine. So let's try to do that. So first I'll copy this binary file to a directory in a Windows machine. I have copied to a directory in the Windows machine. So let's try to execute this binary file in this machine. So let me open a command window. So here let us try to execute hello bin. So it is saying it's not recognized as an internal or external command. That is, it is not able to identify this binary file which was a compiled output in a different machine with Ubuntu operating system. So this is one example where the output of compilation of a C program in one machine may not work in another machine. So we can show like different examples, like if we compile in one CPU family, for example x86 processor, and if we copy the binary to another machine with ARM processor, and if we try to execute there, it won't work successfully. If we need to execute the C programs in different types of machine, we need to recompile the code in every machine. But nowadays the cross compilers are available. That is not the scope of this video. Now let us see the Java program execution. For Java, I have prepared hello.java. This is a small example Java program which prints hello world when we execute it. Before execution, we need to compile this code which will provide bytecode as output. So let's compile this code. So when we compile the code, it has created a class file. We can verify that. Here we can see hello.class. So this is a bytecode and this can be executed by JVM, which is an interpreter. We can invoke JVM by executing Java command. Now we need to provide hello, which is the class name. The code is executed and it has printed hello world. So here we can see the compilation and the execution are two different steps. The compilation produces hello.class, which is a bytecode, and then the JVM, which acts as an interpreter, executes the hello.class. Since this bytecode is portable, that means the hello.class which is produced here, we can copy this to other operating system where we have JVM and then execute from there. So let us copy this class file to a Windows operating system and let's try to execute in that machine itself. So I have copied the hello.class here. So let us try to execute this class file directly without recompiling the code in this machine. Here in this machine we have JVM. That means we can invoke Java command and then we need to mention hello. We can see here that the class file is executed successfully without recompiling the source code in this machine. So this way Java code is portable. That means the bytecode generated by the compilation can be executed anywhere where we have corresponding JVM. Now let us see how the compilation and execution happens for Python programs. So here I have created hello.py as an example. When we execute this Python program, this prints hello world. In Python, we do not have separate compilation and execution steps as in Java. So when we execute a Python program, it internally does compilation as part of the execution as well. That means it compiles the code and then the interpreter, which is also called as Python virtual machine, executes instructions from the bytecode. So here the compilation is part of the execution. So let's execute hello.py here. We can see it has executed and it produced output hello world. Generally for smaller programs, we do not see the compiled file, which is also called as pyc file. But for programs involving imports and so on, we can see a .pyc file generated during execution. Here we can see there is no .pyc file. So if you want to see that .pyc file during this execution, we can include a module called pycompile. So let us do that. Here we can see a directory called pycache. So let us go into that directory. And here we can see a .pyc file is getting generated. We can directly execute this pyc file, which means the Python virtual machine will execute the compiled binary. That means it does not need compilation again. So let's try to execute this file. Now we can see it has printed hello world. This way, by using this PyCompile module, we can see the compilation part as well, which generates the PYC file inside PyCache directory. Now let us copy this PYC file to Windows machine and let us try to execute from there. Since this is a bytecode which is portable, the PVM in the Windows machine should execute this successfully. I have copied the file here. Let us open a command window from this directory and execute this PYC file. So let's execute this. Here we can see that it has printed hello world. That means the Python interpreter executed the bytecode successfully. One thing we have to note here is that the version of the Python interpreter should match the version of this PYC file. That means the interpreter version should be 3.12. Otherwise, we may get some issues while executing this PYC file via Python interpreter. Now we have seen what is a PYC file, how it is generated, but what is the use of this file? These PYC files are used to improve the execution time. Generally, for small programs, we do not see any execution time improvement, but for larger programs, while executing a Python file, it has to compile first and it has to execute the compiled output, which is a bytecode. So during execution of larger programs, if we already have the PYC file, then it will not recompile again, which will minimize the time for execution. That way we can use these PYC files during execution of larger Python files. So in this video, we have seen Python programs are hybrid. That means they are compiled as well as interpreted. That means when we execute Python programs, it initially compiles the files and then the interpreter, which is also called as PVM, executes the bytecode, which is the output of compilation. We also have seen how the Python execution is different from other languages like C and Java, and we have seen what is a PYC file and how it is generated and what is the use of it. I hope this video helps. Thanks a lot for watching.